Hello class, this is the solutions for from the questions January 2011 geometry regions. Alright, so let us look at these questions together. Now, so here it goes. We have in the diagram below, okay, so we have A, B, and we have three sides that are all tangent. Now, as soon as we realize the word tangent and the circle, then one thing that we get to realize is this. That portion line segment is equal to that portion line segment. In other words, BE must be equal to BF. Now, if we're to continue on that idea, AF is equal to 6. That means AD is also equal to 6 automatically. Now, CD is equal to 5. Then here we have CE is also equal to 5. So as BE is equal to 4, then this one is also equal to 4. That's how we can realize. Now, perimeter of the triangle ABC. Now then, we get to realize we just have to add up all of them. So here we have 9. Here we have 10. Here we have 11. So when you add up 9, 10, 11, we'll end up getting 30. Hence, 30 is our answer. All right, let us continue for number 2. Now here we have trapezoid, MN, and then OP are parallel. Now, so we have another image. Now, this one is after reflection over the x-axis, which two sides of the quadrilateral is parallel. Now, if original one was the trapezoid, and even after the reflection, it would still be a trapezoid. In other words, MN, its image, which is M prime and N prime, and OP, meaning O prime and P prime, they will still be parallel to each other. Therefore, choice 1 is our answer. All right, let's move on. Number 3, here we go. In the diagram below, triangle ABC, and then we have these are midpoints. Now, that means the ratio between this line segment and then this line segment, those are 2-to-1 ratio. So therefore, since 4x plus 10 is double the portion of this one, then this line segment must be half of that, which is 2x plus 5. That becomes our final answer. Number 4. Now, every parallelogram, then we need to realize a couple of properties. Every parallelograms, of course, opposite sides are congruent and parallel. That's one thing that we get to realize. And diagonals bisect each other, and also, now, and then also opposite angles are also congruent. Right now, then in this case, one thing, two pairs of opposite sides are congruent. I guess number 3 will be correct answer. Yes, we do have one more, which is opposite angles, as I mentioned just now. Opposite angles are also congruent to each other. All right, number 5. Now, coplanar, co as in together, planar as in plane. Then, which two lines are basically on the same plane? Now, AB and DH. AB is right here. DH is right here. Obviously, they are skew lines, meaning they're not in the parallel. They're not parallel, and then they are not in the same plane. Now, next one will be then BC, which is right here. BC and then EH. Oh, in fact, you see, we realize that those two lines can be in the coplanar, meaning same plane, when you set up the plane diagonally in this way, I guess, some sort of something along that line like this. If the plane that goes across in this area, they can be planar. All right, now the rest of them we don't actually have to check. There will be all skew lines. All right, let us move on. Here, so we have endpoints of these two. What midpoints? How do you find the midpoints? Now, formula for the midpoint is x1 plus x2 over 2 plus comma, not plus, y1 plus y2 over 2. But this is essentially the average of those two x values and then those two y values. So we end up getting 7 and negative 3. 7 plus negative 3 over 2. Now, the y values are negative 1 plus 3 over 2. Once you do this one, this will be equal to 7 minus 3, which is 4 divided by 2 is 2, and then 2 divided by 2, which is 1. So 2 comma 1 becomes our final answer. Alright, here, translation, that means all we have to do is apply this movement onto these corresponding values. So, what's going to be happening is negative 5 will be added on to 3. So we have our new value will be negative 5 plus 3. In case of y value, 2 will be added on to negative 4. So we end up having 2 plus negative 4. That's it. That's our answer. So we have negative 2 on the x values. Here we have another negative 2 on the y values. So our answer becomes choice number 3. Alright, here. Two angles are congruent. Two angles. Supplementary angles, they don't have to be congruent. Linear pair, which is same thing as supplementary angles. Adjacent angles, no. Aha. But on the other hand, vertical angles. Vertical angles are the angles that are being formed by two intersecting lines, as you know. Here, then no matter what it is, we will realize that this angle is always equal to that angle. That's what they're talking about in number 8. Number 9. Now, plane R is perpendicular to line K. Now, then imagine we have a plane right here. Okay, that's one plane. Of course, it extends in all directions, but perpendicular to line K. So, imagine this is the perpendicular line. Now, and plane D is perpendicular. Now, if plane D is perpendicular, then what's going to be happening is this. We're going to have another one. So in other words, this is R, this is D. If they are perpendicular, then this one will also be perpendicular too. Hence, they are parallel to each other. Number 10. Now, centroid. In fact, centroid will be a connection between three medians. So let us look into this one for a second. The first median will be from A, coming down here directly, because we have 4 units and 4 units. In case of B, you can connect the line from here, and then a midpoint will be around here between these two. So if you connect it, then you will realize that right here, that becomes a point of intersection between two medians, which is how that centroid is defined. Now, when you try to read this point on, then we'll end up getting 3, 4, 5, 6, 7, and then, so we already 3, and then 4, 5. 7 comma 5 becomes our answer. Now, another way for you to do it is this. In fact, centroid is in one way connected by the medians, where medians are the connection between vertex and midpoint. Interestingly, in the coordinate geometry, given that given that everything is square based, then what's going to be happening is average of all points can be centroid. In other words, let's look at x values 7, 3, 11. So when we get the average of those to 7 plus 3 plus 11 over 3. Wait a minute. Then that becomes 21 over 3. Aha! No wonder we get 7 over there. Now, second one is this. 9, 3, 3. 9 plus 3 plus 3 over 3. What do we get? We have 15 divided by 3, which is 5. So that's right. Average of all points becomes centroid. Number 11. Which one of them does not represent the sides of the right triangle? Sides of the right triangle is basically Pythagorean theorem. So which one of these doesn't satisfy this Pythagorean theorem? Now, in fact, the answer will be number 3, because if you think about it, this is 3, 4, 5 triangle, double. And 5, 15, 5, 15, 17 will also be true, because if you square 8 square plus 15 square equals 17 square. Let's see, that becomes 64 plus 225. Now when you add them up, we get 289. In fact, yes, 289 is indeed square of 17, so this one also checks out. And this is 8, 15, 17 is another popular triple, which is not as popular as the other two, but you know, this will be the one. Now here, I'm not sure if you noticed it or not, this is 5, 12, 13 triangle. When you multiply each side by 3, then you're going to get that. And in fact, in this case, the correct one would have been 7, 24, 25 would have been the right triangle side, but 8, it wouldn't work. When you do the square Pythagorean theorem, you will realize that they will not be equal to each other. So therefore, our answer is choice 3. Now, let's see. So here we have a rhombus. Wow, it's a huge rhombus. So C is equal to 100. Then what's the measure of the angle? DBC. So DBC here, this side is in fact equal to this side, which makes this triangle to be an isosceles triangle. So 100, that means 180 minus 100 would have given us 80. But that 80 is in fact sum of these two congruent angles. So that when you divide them by 2, you will get 40 as your final answer. Alright, here, let's look into this picture. Once again, this picture is also quite interesting, because when you look into this one, OC is 5, meaning the radius is 5. Now, chord AB is 8, but when it is cut with the radius, then you will realize that each one will be equal to each other, so 4 and 4. That's what we end up getting. Now, then one thing that we get to realize is this. What is the length of OP? So since if you want to find out what OP is, let's call that as X. Then this one is 5 minus X. And here in fact becomes, if you extend this idea, this line further, then this essentially becomes from here to here 5 plus X. In other words, when we this is the idea between circle and 2 chords. If I draw the picture, circle and 2 chords meeting up, then you will realize that here this is A, B, C, D. Then the formula was A times B, which is equal to C times D. Now, if you to apply that here, we will end up getting 4 times 4. Is that same side line segments from the same chord, and then that's equal to 5 minus X times 5 plus X. Now, then when you calculate this one, it becomes 16, which is, this will be the difference of perfect squares, in fact, sum and difference, so 25 minus X squared. Now, then what's going to be happening is, let us subtract 25 each, then we get negative 9 is equal to X. Negative X squared, where X squared becomes 9. And X then will be equal to 3. That's how we can solve this question. So XOP, which will be equal to 3. Alright, let us move on. What is an equation of the line passing through this? And then parallel. Since it has to be parallel, they have to have the same slope. Slope has to be 3 over 2. That missing maybe this one, or this one, or those two, I guess. But it has to satisfy that when you plug in negative 2, your y value has to be equal to 3. When you plug in negative 2 here, for example, 3, is that equal to 3 over 2 times negative 2? In fact, when you cancel them out, you end up getting 3 has to be equal to negative 3, which they are not equal to each other. So on the other hand here, we get 3, which is equal to 3 over 2 times negative 2 plus 6. Then we end up getting the first portion becomes negative 3 plus 6, which is in fact equal to 3. So it checks out. So fourth one becomes our answer, number 15. Now in a scaling triangle, okay, what are the orders? Now basically what's happening here is this. Angle B and angle C are 45 and 55, so if I had to create a triangle, approximately it can be something like this, I guess. So here I'm gonna just, this is not drawing into scale, but 45, and then let us say this is 55. And when you add them up, you end up getting 100, which makes this one to be equal to 80. Now, then what we end up getting is, longest side is the opposite of the biggest angle. So here B was 45, C was 55, then this must be A. What is the law of biggest angle? Obviously it's 80. Opposite of that, which means BC is the longest. So we're looking for something that has BC in the front. Now, second one is 55. That means opposite of 55. Once again, opposite of 55 get us the second longest, which means AB. So BC and AB. That seems to be our answer. Now, here, this is rather simple, a very simple question, because equation of a circle becomes x minus h squared plus y minus k squared, which is equal to r squared. Now h comma k, as we know, activity, center, and r is equal to the radius. So radius is 4, that means we have to have a 4 square at the end. One of these two. Now, first number is 7. That means notice that there's a negative sign embedded in it already. So instead of having x plus 7, it will be x minus 7, because this is plus. Choice number 3 seems to be our answer. Now, what is the volume of the cylinder? In fact, the volume of the cylinder is base area, you see, times height. It's always base area times height. If two bases are equal to each other, and then all the cross sections are equal to each other, then here, how are we going to find out the base area? It should be pi r. Since diameter is equal to 12, r, the radius will be equal to 6 square. Now, height will be equal to 15, so we just have to multiply that by 15. Now, once you multiply 15 times 36, then we'll end up getting, I believe this becomes 540 pi. Therefore, the answer will be choice 2. Now, number 18. Now, in this connecting word is and, that means it has to satisfy both sides, which will be true here, but not the other one. Quadrilaterals has 4 sides. If and only if, that's the biconditional statement, which only truth value for the left and right side has to be equal to each other for them to be true. But here we have triangles. Yes, they do have 3 sides, so therefore true, but here it's not. So therefore that's not going to work. The answer will be basically or, because or means as long as one of these two are equal, truthful, then the whole statement will be true. So the answer will be choice number 4. Now, next. Alright. Now, in order for us to see what's actually happening, it may not be bad for us to write it in terms of y equals mx plus b. So by subtracting x, we get 6y will be equal to negative x plus 12. As you divide by 6y is equal to negative 1 over 6x plus 12 divided by 6 becomes 2. Alright, that's basically what happens to the first one. How about the second one here? All I have to do is simply adding 4, then we end up getting 3x minus 6, because 3 also multiplied to negative 2. and then adding 4 to both sides, which gives us this. Now, then in this case, y then is equal to 3x minus 2. Now, what do you realize about the slope? They're not negative reciprocal. No, they're not the same. So in fact, they're not perpendicular. They're not parallel. They're not even same line because the expressions are not the same. So therefore, they must be intersecting on an angle other than 90 because they're not perpendicular. All right. Now, perpendicular bisector. Which one will get us the perpendicular bisector? The answer will be choice, in fact, 1. Here it does specify about the bisectorizing these two are equal to each other, but we're not sure if it's a perpendicular or not. Here simply what they're saying is this point is on the line that is equidistant from this particular point to this particular point. But it's not even a complete construction, so that wouldn't be great. And this one simply talks about the perpendicular line sigma. We don't really realize about the equal to each other or not. So that therefore our answer is choice 1. Okay, what is the length of the diameter? If the endpoints are such, length of the diameter basically uses the distance formula. Now then, distance will be equal to square root of x2 minus x1. Oh, so, or if you want to go for negative 6 minus 4 squared plus here 3 minus negative 5 squared. Then here we get square root of 10 squared plus here we have 8 squared. Then we end up getting 100 plus 64, which ends up being square root of 164. Now when you factor out, when you simplify this one, this becomes 2 square root of 41, because here we have square root of 4 can be factored out, which gives us 41 as its value. So therefore, 2 radical 41. Choice 4 becomes our answer. Now, AB is parallel to CD. Then ABC, this angle is congruent to CDA, right here. Now, the question is this. How can we prove that these two are congruent? In fact, these two are same angle, and one possibility, I'm going to try to do this one with maybe red, that is, this angle must be congruent to this angle by alternate interior angles being congruent to each other. And of course we have reflexive, and it seems that the easiest one would have been angle, side. So therefore our answer will be this one. Alright, let us move on. Here we have BD is what we are looking for, BD. So what am I call this one as X? And if you use the two-phase method, we will end up getting 6 squared, which is equal to X, which is outside, times the whole thing, which is X plus 5. Now, once you calculate this, when this one becomes 0 here, we have X squared plus 5X minus 36. How are we going to calculate this one? Two numbers that multiply to 36, but difference is 5. That means this can be factored into X plus 9 and X minus 4. Now, then here, we know that X cannot be negative number, but it has to be positive number, so X has to be equal to 4. That means our answer will be choice 4. Alright, let us move on. Now, here we have opposite angle J and M. We see, in fact, this quadrilateral is inscribed in a circle. Its name is called Cyclic. Quadrilaterals. Or I heard some other people calling cyclic, but either way, in the special property of this one is that opposite angles are always supplementary. That's basically what we're looking at, because whatever this one is, this will cover from here all the way up here. Now, on the other hand, this angle basically is half of all this. But when you look into that, you will realize that these two basically angles cover the entire circle. But we just have to cut in half, so therefore they must be supplementary. Alright, let us move on. Here once again, radius has to be 2. Which one of these has a radius of 2? Because the side is equal, the last number is equal to 4. So it can be one of these. Now, second, where is the center? Center is what? 3 comma negative 1, you see? 3 comma negative 1. Aha, this looks like our correct answer. Alright. Excuse me. Now, rotating 90 degrees. Now, rotating 90 degrees, then what's going to be happening? 3 comma negative 2. When it's rotated by 90 degrees, then what's going to be happening is switch them and then negate the first one, so we end up getting 2 comma 3. Now, but after that, we have to go through dilation by a factor of 4. That means we just have to multiply them. We end up getting 8 comma 12. That becomes our answer. Alright, so this is another very popular picture here. Angle A is x, right over here. B is 2x plus 15. And third one is 5x plus 5. So the relationship is on exterior angle is sum of two remote angles, which we now have. So 5x plus 5 must be equal to x plus 2x plus 15. Then here we have 5x plus 5, which is equal to 3x plus 15. Now when I subtract 5 from each side, and subtract 3x from each side, then we get to realize that x must be equal to about 5. Then angle B now becomes 2 times 5 plus 15, then we end up getting 25 to be our answer. Alright. Point P lies on line M. Point P is also included in a distinct plane Q. So that means when we have at most, how many of these planes could be perpendicular to line M? In fact, once you have a plane and a particular point, and let's call this one as P. But the what's happening is, at most, how many of these planes could be perpendicular to line M? In order for it to be perpendicular to this line will be something like this. And then you will realize that this will be also, there's only one way which you can do that. Alright, so let us continue here to number 29. Now, we have, this is an equilateral triangle. So that means we're looking at this one is 60, 60, and 60. Now, at the same time, we have DB is equal to BC, which is this one. That means this angle must be equal to this angle too. Now, let's look into this one, because here by the supplementary angle, this is 120. That makes these two angles must be 30 and 30. Oh, okay, we got it. Angle C is equal to 30. Alright, next question. We have 3 points here. Now, after transformation of reflection about the x-axis, that means, so A, negative 2, comma 2. When it's rotated, reflected about x-axis, then what we end up getting is this. X value stay, Y value gets negated, so we have A prime becomes -2, but also -2. Now, B, here we have -1, comma -3. Now it becomes B prime. X stays, Y gets negated, so 3. Now C, which is 4, comma 0, C prime, in fact, still become 4, comma 0 because we cannot negate 0. And I guess that's it. Alright, let's move on. Both interior and exterior angles of the regular pentagon. Now, how do you find the interior angles? Of the regular polygon becomes n minus 2 times 180. That gets you the sum of the angles, but we gotta divide by n. Then we will end up getting the measure of an interior angle. So we end up getting here, we have excuse me, 5 minus 2 times 180 divided by 5. Now once you do this one, we'll end up getting 108 becomes our answer. Now, on the other hand, measure of an exterior angle can be found by, there are various ways, but some becomes 360, so we just have to divide by n. Then we end up getting 360 divided by 5, which will be equal to 72 degrees. Notice that they are always supplementary. Alright, let us move on. Number 32. These are 8 and 9, but AB is bisecting CD, so this can be x and x. Then what are we end up getting? X squared will be equal to 8 times 9. Now, which is equal to 72. That's x equals. Then x must be equal to square root of 72. But what makes 72? That's in fact square root of 36 times square root of 2. Square root of 36, we know that to be 6. So hence 6 radical 2 becomes our final answer. Alright. Now, angle bisector. Okay. How are we going to do that? First, we have to get the compass. And then just take this one out with a certain distance and just draw on an arc. Now, next, go to that point, and then we might need to extend it a little bit further to the point where we can have two arcs intersecting each other here. So one over here, without changing anything. Notice that this will be the intersecting point. So with the ruler, what you can do is let me bring down the ruler here. Okay. And then draw the line. There it goes. That becomes an angle bisector right there. Alright, let us move on to the next question. Number 34. Slope of the perpendicular line. Now then, let us try to put this one into y equals mx plus b format. Then 2y must be equal to 6x plus 4 by adding 6x from both sides by dividing by 2 all throughout. Y equals 3x plus 2. Now, here, from at this point, slope of the line is perpendicular. That means it has been negative reciprocal. So therefore, 3 now becomes, slope of the perpendicular line becomes negative instead of positive. Reciprocal of 3 becomes 1/3. So this becomes the slope of a line perpendicular to that equation. Now, here, locus of points that are 4 units away from 2, 1. 2, 1 is right over here. 4 units away, essentially we're talking about a circle. And then, it is before units away 2, 3, about 4 units away right here. Now, and on the same locus of points that are 2 units from the line x equals 4. X equals 4 here. X equals 4 is this way. Alright, so extend this one. And 2 units away, that means we're looking at 2 units away from here, that means we can have one line right over there. And that's another one. Now notice the circle is a little bit off track, so that's why it looks a little bit off, but that's exactly what should happen. Now here, state the coordinates of all points that satisfy the both conditions. Then essentially we're looking at this one. No, I'm sorry. This one, and this one. Coordinate of this one becomes 2, 4, I believe, 6, 1. Another point is 2, 1, 3, 5. 2, 5. Here becomes 2, -1 and -3. So those are the 3 points that satisfies the given condition. Alright, let us move on. Okay, so we need to prove that 2 triangles are similar. So how are we going to do it? In fact, AB is perpendicular to BE. That means this is a right angle. And then triangle ABC and then DEF. We just have to show that 2 pairs of angles are congruent. And one pair is that. Another pair is in fact due to another perpendicularity right here. We already proved one pair of the angles. The other pair is BFD. BFD. Haha. That angle must be congruent to ECA. ECA. Now, but let us look into this one. What's going to be happening is, this is an exterior angle, sum of right angle and a dot. See, a right angle and a dot would have made this angle. But since this angle is the same as this angle, we already have the right angle. That means the other one must be also dot. So we see 2 pairs of the same angle. Therefore, these 2 triangles must be similar. Okay, that's simple. Well, we could use another way, which is we could also use these 2 pairs, by supplementary idea. That's perfectly fine too. All right, number 37. Now, here we have such that B's, they're all parallel, and then find the length. AC is x minus 3. And then BE here is equal to 20. And then AB is equal to 16. And AD is equal to 2x plus 2. And essentially what we're looking at is this. We're looking at the upper line segment of the whole thing, so then the ratio becomes x minus 3 over 2x plus 2. Now, that must be equal to 16, which is same proportion, over the whole thing, which will be 36. Now, then when you cross multiply them, you will end up getting 36 x minus 108, which is equal to 32, because 16 times 2 becomes 32, x plus 32. So when you subtract 32 from each side, we will end up getting 4x. And adding 108 to both sides, we end up getting 140. So therefore, x must be equal to 35. Yep, that's it. but we are trying to find the length of AC. So from 35, AC then will be equal to 35 minus 3, which is equal to 32. All right, there it goes. Next. Prove that it's a rhombus and it's not a square. So in order for us to do that, we're going to just get the graph and then we'll try to plot those points. Then it'll be so much easier to look at. All right, so we have 1, 1. And then negative 2, 5. And then 6, 1. We forgot 3, 5. 3, 2. So M A whoops M and A and T and H. All right. All right, so how are we going to prove that these are rhombus? We just have to show that all sides are equal to each other. That's one easy way of doing it. So let's see. What are the distance of A? AT you can just count it to 5. So we know that AT is equal to 5. And then how about TH? TH we have to use the Pythagorean theorem. So we have 4 and then 3. So all distance formula. Okay, so we get 6 minus 3 square plus 1 minus 5 square. Once you try to calculate this one, 3 square plus 4 square, we will end up getting 5. TH. Now, MH, we can just count the boxes, which is equal to 5. And so is MA. Using the similar logic, we will end up getting negative 2 minus 1 square, and then 5 minus 1 square. So once again we end up getting 5. Therefore, since all sides are equal, MATH is a rhombus. Now, on the other hand, it's not a square. So how are we going to do that? We just have to find the slope. Now, so then what is the slope of MH? Will be equal to 0. In consecutive sides, then maybe AM. And what is the slope of AM? Then that's equal to you're going up by 3 units, but coming down by 4 units, so negative 4 over 3. And as we can clearly see that the slope of MH is not negative reciprocal of slope of AM. All right. This proves that this is not a square. All right.